Wendy agreed to make 3 payments of $6,000 each in 1 year and 3 years and 5 years respectively. Because of initial cash flow difficulties, Wendy offered to pay $8,000 in 2 years and a second payment of $10,000 at a later date. We don't know what that date is. When should she make the second payment if interest is 9.75% compounded semi-annually? So let's start off with a time diagram here so that we can fully understand this problem. Wendy has originally agreed to make payments of $6,000 each in year 1 and 3 years and in 5 years. So there's the 3 $6,000 payments. So that was her original plan. She's going to replace them. So the original debt was 6, 6, and 6 at these respective times. Now we're going to replace them with an alternate payment scheme, and we're going to replace them with payments of $8,000 in 2 years' time, so $8,000 in 2 years' time, and another payment of $10,000 at a later date. Now I don't know when that later date is, so I'm just going to arbitrarily pick some later date. I'll just use N for that date, and that it'll be a $10,000 payment. And what we need to do is to determine when it's going to happen. What is the value of N? How many interest periods are there? So the interest rate is 9.75% compounded semi-annually. So at 9.75% compounded semi-annually means that the I value is 9.75 divided by 2. Let me see now. That would be 9.75% divided by 2 per 6 months. Okay, and we'll set that aside for the time being. But how are we going to determine how many interest periods there are? Well, in order to answer this problem or solve this problem, we need to come up with a focal date. We now have the time diagram, but let's select a focal date. And the best focal date to choose, or the simplest one to choose in my opinion, would be today's date, because everything can be discounted or brought back to today's date. So there's my focal date right here. We'll choose this as our focal date, and we'll say the present value of the 3 debts, that would be the $6,000 each of them, discounted and brought back to today's date, should be equal to the present value of the replacement payments. And so we can equally discount the present value of those 2 replacement payments. So I'm going to say right now that the present value of the original debts, the 3 payments of $6,000, is equal to the present value of the replacement payments. So let's work out what those present values are on the other page. Judging from my time diagram, I should probably go back to that time diagram again. Judging from the time diagram, you can see that since the interest is compounded semi-annually, we're going to determine the number of interest periods for each of the $6,000, and in 1 year we have N is equal to 2 interest periods, but since we're discounting, we're going to use a negative N exponent. For 3 years, N is equal to 3 times 2, or 6 semi-annual periods, and for N is equal to 5 years, the number of interest periods that we're going to be discounting that third payment is 5 times 2, or 10 semi-annual periods. On the other side of the time diagram, we have the payment of $8,000, and it's going to be discounted over a period of, over 2 years. It's going to be a period of 4 semi-annual periods, and here N is going to be the number of semi-annual periods. So now on the next page, let's come up with our equation. So starting off with the present value of the 3 payments of $6,000, the present value of the 3 payments, or the 3 debts, is going to be $6,000 multiplied by 1 plus, well, that would be 0.0975 divided by 2 raised to the exponent negative 2 plus $6,000 times 1 plus the interest rate raised to the exponent negative 6, where the interest rate I'm going to use is that interest rate. And I'm just not going to write it out every time, plus another $6,000 discounted at 1 plus the same interest rate raised to the exponent -10. And when I add those three amounts up, we're going to end up with a value of $13,692.18. And that should equal to the present value of the replacement payments. So the present value of the replacement payments is going to be equal to, well, let's see, starting off with the $8,000, I've got $8,000 discounted, of course, because I've got to take it back to today's date, so it's going to be 1 plus the interest rate, which is 0.0975 divided by 2, raised to the exponent -4, plus, and now we have the $10,000 that we also need to discount, and that's going to be $10,000 times 1 plus I, whatever that interest rate is. And again, we're going to be using this interest rate here, this factor, raised to the exponent -n, because we don't know what n is. And this works out to be an amount of 6613.05 plus $10,000 times 1 plus I to the power of -n. Well, what's on the left side of this equation is $13,692.18, because the replacement payments are going to be equal to, have an equivalent value of the debts. And so now if I'm going to solve this equation for n, what do I have to do? I'm going to start off by subtracting $6,600 from both sides of the equation. So when I subtract $6,600 from both sides of the equation, I end up with, on the left side, 7079.1256 is equal to $10,000 times 1 plus I to the power of -n. And now, in order to solve this equation, what I will need to do is to divide both sides by 10,000 so that I can isolate the factor containing the n exponent. And this works out to be a value of 0.7079, etc., is equal to 1 plus 0.0975 divided by 2 raised to the exponent -n. Now, in order to solve an exponential equation, which is what this is, we need to use logs. And in our case, we're going to use the ln function. So the ln function is going to give us a new equation that says ln of 0.7079, whatever's on your calculator display, is equal to minus n times the ln of 1 plus 0.0975 divided by 2. And so minus n is equal to the ln of 0.7079 divided by the ln of 1 plus the rate, 1 plus 0.0975 by 2. This works out to be a value of -n is equal to -7.257, and of course the double negatives are going to cancel out. We end up with 7.3, approximately 7.3 semi-annual periods. So n is going to be equal to 7. Well, just to make that 26 semi-annual periods. That's a little bit more than 3 years. It'll be approximately 3.6 years, or 3 years and 8 months.